Hello and welcome to the next of my overviews of the GCSE Maths course. In this one we're going to be looking at geometry, which is really the study of spaces and shapes and angles. The subjects that we're going to cover, each of these subjects I'll briefly discuss. I'm not going into depth. This is only meant to be an overview of some of the things that you're going to meet in a GCSE Maths course. Okay, shapes, angles, coordinates, transformations, Pythagoras and trigonometry, constructions, congruence, vectors. Okay, so first off, shapes. In shapes, we'll look at the properties of some shapes, particularly rectangles and squares, triangles and circles. A polygon is any shape, in fact a square is an example of a polygon. A polygon is any shape which has got multiple sides, really. It's quite a general word. So I'm just going to pop over to my some diagrams here. So here are some shapes. There's a regular hexagon, that's an example of a polygon, equilateral triangle, a diamond or a rhombus, and a kite. And I've drawn that line down the triangle to show one of the properties of shapes you're going to look at, which is symmetry, and a triangle has reflective symmetry. Okay, let's pop back to my slides. Angles, but what are we going to look at it with angles? Different types of angle, angles between lines, and angles in triangles and circles, which I'm not really going to cover in this video. But I'm going to have a quick look on a slide here where we've got delete that. Just closing something down I was looking at before starting. Before we start looking at angles and different sorts of angles, I just want to show you these are two things that you really need to buy for yourself: a protractor and a compass. First is for using measured angles, the second one for drawing circles and various other things we're going to be talking about later for constructions. If you own your own ones, you'll get used to using them. Everyone feels a bit different. You need them in the exam. I suggest you buy them as soon as you can. So here are the different sorts of angles: a right angle, an acute angle, and an obtuse angle. Now, right angles you can see all around you: corner of your house, corner of your window, corner of your table. 90 degrees. Acute angle is any angle which is less than the right angle, and an obtuse angle is an angle which stretches out a bit further than the right angle, and they are greater or less than 90 degrees. Okay, now on the right there we've got a diagram where I'm going to show you how we can sort of talk about finding angles from other angles. Now, there are three particular rules here which are useful. Opposite angles, well, that looks obvious. We've got a junction of two lines, and opposite angles are on opposite sides of the junction. So we can tell you one of the rules is that opposite angles are always equal, and you can see that that red angle, those two red angles, are equal. We've not measured them, but you can kind of see that they are. Now, the other two sorts of rules about angles that you need to remember are corresponding angles. Now, corresponding angles happen when we've got two lines which are parallel and another line crossing them. And the third one is called alternate angles, which I'm not going to show you now. You'll learn about what alternate angles are. And when you do questions where you've been asked to find out angles from other angles, it's important to use these words to describe that you understand the patterns and why you know the angles or what they are. Okay, let's move on. So this is something I added to this video since I had to go recording it last week. Coordinates, how do we describe a point in space? Which is something that's very useful to do. Right, so I've divided this space up into squares, and put the numbers on the what we call the axes, and any point on this diagram we can now describe by using two numbers. So I'm just going to put a cross there and work out where that point there is. We do this by counting 2 along and 3 up, and that's 2. The along number always goes first. 3, 2, 3. Okay, so that's the point 2, 3. Now get yourself a bit of paper and draw a grid like that, and you can probably point it on the line and see if you can work out what the coordinates are. Okay, that's coordinate geometry, which we use also in algebra, so it's very handy to remember how to do that. Transformation. Now, transformation is just a change in a shape, and there's various sorts of transformations you'll be looking at: translations, reflections, and rotations. And a little bit later, I think mainly if you're studying with a higher paper, enlargements. Okay, so let me just pop back to here. Now, think of this as the first shape, and this shape, if you can see, is just been reflected in the line down the middle, the y-axis, and each is flipped over. And you can only imagine if you're in the position of one shape, the other shape is like in a mirror. So that's what a reflection is. And rotations and translations have other rules. They're just moving the shape around the space. As I'm not going into detail, I just recorded this video once. It came out in half an hour, so I'm trying to make a slightly shorter version because it's only meant to be an overview. Okay, Pythagoras and trigonometry. Now, the Pythagoras theorem comes under this heading, and a little bit further down the line, trigonometry. And both of these two things relate to trying to find out things about triangles that we don't know, particularly right-angled triangles. Now, what we have there is a right-angled triangle because the angle in the corner, down the bottom corner there, is a right angle. And the line opposite the right angle we call the hypotenuse, or today I'm just writing H for it. The other two sides we can give any letters, but I'm giving them A and B. And then we can write Pythagoras' rule by saying H squared, H times H, equals A squared plus B squared. And that will be true of any right-angled triangle. Now, when I'm actually tutoring this subject for real, rather than just giving an overview of it, I let the student find this rule out for themselves by drawing a few triangles. But that is the rule for Pythagoras' theorem, and we can use it to, if we know two sides of a triangle, a right-angled triangle, you find out what the third side is. Trigonometry takes Pythagoras' theorem a little bit further, and we can use it to work out other things about. We can work out the angles of a triangle, and higher students will take it a little bit further and make it work for triangles which are not right-angled triangles. But that's as far as I'm going to go with trigonometry for this video. Constructions and maps. I'm not going in detail in this video, but you can use that with the pair of compasses which I showed earlier for drawing circles. We can use those to do things like dividing an angle in two and drawing perpendicular lines. We're just constructing them. That's why they're called constructions. And also on the same heading, we've got scale drawings, which like map drawing. We can draw a little map of your living room or your study area. And also bearings, which is where we're using angles to find our way around maps. Again, giving you that as a heading for now, not going to go into detail in this video. Congruence, now similar shapes and congruent shapes. This is where we're looking at two different shapes and trying to work out how they relate to each other. And similar and congruent are two descriptions of relationships in two shapes, basically, which again, I'm not going into any more detail in this video. The last slide here is vectors. Now, when we were showing the coordinate geometry earlier, we had a point Vector is using numbers not to describe a point on the graph, but movement on a graph. Let me just pop back to our whiteboard here. Now this is a vector, and it says moving from A to B. But actually, we write a vector. If you remember, I wrote the points that way, and that means the point 2 along and 1 up from the middle of the graph, what you call the origin. But this doesn't describe a point. This describes a movement where we're moving 2 to the right and 1 up, and that we can do that from any starting point, and the end result will be different. But a vector describes a movement, and if you're studying for the higher paper, you will be learning how to add vectors, subtract vectors, and basically work out patterns with vectors. And we can use vectors to do things like proving lines are parallel. Again, not going into detail. Now, I'm fairly certain I've just done everything on my so that's good. So now let's have a look at a couple of exam questions. I'm not going to do these exam questions in depth here. This one here, this is a question about, well, we've been given a coordinate grid with a shape on, a triangle T, and we've been asked to rotate the triangle, which is an example, which is a transformation I've not really given you the detail of. So we'll have a quick look at the second part, where it says reflect the triangle in the line x equals minus 1. Well, the line x equals minus 1 is this line here. Let's have a look. That's on that line there, x equals minus 1. So if we're going to reflect this shape in this line, then I'm just going to change the color. We've got 1, 2. That bottom corner is 2 to the left. So the shape we're going to create is going to be 2 to the right. And then this point here is 1, 2, 3. So for a reflection, we just move 3 the other side, and it ends up there. And the last point is going to end up there. And we can join those up. And that is the shape T. You'll see that the shape retains its basic, it's still a triangle, but it's moved, and it's moved by the transformation called a reflection. And then we're not going to do the rotation now, because I've not really shown you how to do rotations, but that's something else you'll learn in your GCSE maths course. Now this last one is an example where we're being asked to work out what this angle is here. Now this is, again, I'm not going to do this one now, but the sorts of rules that we can use to find out what that angle is that's been drawn on there, but not no line. We've been given 2 of the numbers of angles. We've not been given the one we're trying to find. We've been told that the bottom and top lines are parallel. We do need that, and then we'll use rules like what do the angles on a triangle is up to, and those rules I discussed briefly a few moments ago: opposite, alternate, and corresponding. And we basically use those rules. We can work out what the angle BDC is. Okay, so there we go. In this brief overview of all the things in the geometry part of the Maths GCSE courses, I've shown you a little what all the things you'll be studying is. I've shown you a few examples of some of them and a couple of exam questions. So I hope that kind of makes you feel ready. You probably won't do the geometry straight away. You'll probably do number skills and maybe some algebra to start with, depending how your teacher organises the course. But it's part of the, sometime in the Maths GCSE course, you will be studying, depending whether you're doing higher or foundation paper, most or all of the things I've covered in this video, and you'll be able to answer questions like that on your own. So there'll be another video coming up later over the weekend or tomorrow where I'm going to go through area. This is one of my longest videos, and so I split area and volume off to another video, and that one will be posted very soon. Thanks very much for watching.